Humanity and the Cosmos. At the dawn of a new astronomical era, humanity has always looked at the sky with awe. Once we saw gods and fate in the stars, then the mysteries of nature, and today the uncharted frontiers of the future. Astronomy and space are no longer abstract domains of science. They have become a window into what awaits us beyond Earth. We've entered an era where more discoveries occur in a single decade than in entire centuries before. Space has opened its doors wider than ever, and we have already crossed the threshold. One of the most recent scientific achievements that shook the astronomical community was the capture of unprecedented images of the Sun's south pole, thanks to the Solar Orbiter mission. Never before had humanity observed the Sun from such an angle. The Sun's south pole, once inaccessible to direct observation, is the birthplace of processes that influence solar activity and even Earth's climate. Now we can see how magnetic fields are formed, how sunspots emerge, and how cycles vital to our planet, from radio communication to astronaut safety, come to life. While we peer into the heart of our star, discoveries at the edges of the solar system are no less thrilling. Saturn, the ringed beauty, continues to surprise. New observations have revealed several previously undetected moons with unusual orbits. Some may be captured asteroids, others remnants of ancient collisions. Moons like Enceladus and Tethys show signs of internal heat and cryovolcanic activity. Beneath their icy shells may lie oceans, potential cradles for microbial life. Looking toward the stars nearest to us brings just as much inspiration. The Barnard's star system, only 6 light-years away, offered a surprise. The discovery of exoplanets, including Barnard B, located on the edge of its habitable zone. Despite its extremely low temperatures, subsurface liquid water may still exist, bringing the possibility of simple life forms. This strengthens the hope that habitable worlds might be far more common than previously believed. But space is not just a source of wonder. It also carries threats. For example, asteroid 2024 YR4, discovered early last year, quickly caught the attention of global agencies. Although the risk of impact with Earth is extremely low, its mere discovery reminds us of the fragility of our civilization. The response was swift. Tracking systems were activated, new calculations made, and engineers began developing deflection strategies. The successful DART mission, which altered the orbit of a small asteroid, proved we can defend our planet. But more investment, surveillance systems, and defense technologies are needed, and fast. Beyond the solar system lies a realm governed by different laws, where gravity bends space and time, and a single pulse of light can reveal more than 1,000 images. This is the nature of black holes, once theoretical, now observed. After the first image of a black hole's shadow in galaxy M87 in 2019, scientists turned their focus to the center of our own galaxy. By 2025, we expect an image of Sagittarius A/F, the supermassive black hole around which the Milky Way rotates, an event that could unlock physics beyond Einstein's theories. Space is not just visible, it's now audible. Gravitational waves, recently discovered, allow us to listen to cataclysms billions of light-years away. Black hole collisions, neutron-star mergers, even primordial waves from the universe's birth. This marks the birth of gravitational astronomy, peering where light cannot reach, revealing previously invisible events. As some instruments detect the universe's past, others, like the James Webb Space Telescope, look into the early eras of star formation. Webb has captured galaxies formed just 300 million years after the Big Bang, findings that reshape our cosmological models and raise the possibility that life in the universe may have emerged far earlier than we thought. Its successors, like Louvois and Roman, will be even more powerful, able to detect the atmospheric compositions of exoplanets, trace oxygen, methane, water, and even hints of artificial structures. But humanity doesn't intend to remain a passive observer. Artemis missions have already led to the construction of the Gateway Station in lunar orbit. The next step is Mars. Efforts are underway to develop autonomous life support systems, grow food in low gravity, and drill for water deep below the surface. These aren't sci-fi fantasies. They're preparations for future crewed missions. Nuclear propulsion could shorten the journey to Mars and beyond to Jupiter's and Saturn's moons. Yet, all of astronomy, all of space science, is not just about technology and equations. It is, at its core, a story about us, about how humans left the cave, looked to the heavens, asked a question, and never stopped searching for the answer. We, the children of stars, keep returning to them. Space is not just out there. It's within us. We are made of elements forged in stellar cores. Every atom in our body is a remnant of some ancient, dying star. Today, space is both a mirror and a window. It reflects our thirst for knowledge, our fragility, and our capacity for infinite growth. And it shows us a path, difficult, yet thrilling. A path that may one day lead us to new worlds, new life forms, and perhaps to a deeper understanding of the very essence of the universe. From rivalry to cooperation, alongside scientific progress, the structure of international cooperation in space is undergoing revolutionary changes. Once the domain of geopolitical rivalry, a cold race between superpowers, space is now becoming a platform for global collaboration. NASA's Artemis program is a prime example of this new era, involving dozens of countries: Canada, Japan, EU nations, Australia, and newly joined states. Together, they build modules, carry out missions, share data, and pool knowledge for the benefit of all humanity. Yet another striking trend is the rise of private space companies. SpaceX, Blue Origin, Rocket Lab, and dozens of startups around the globe are pushing the space industry forward at an unprecedented pace. For the first time in history, rocket stages are reusable. Hundreds of satellites can be launched in a single flight. Mega constellations provide global internet coverage, and the cost of reaching orbit is plummeting. The illusion that space belongs only to governments is fading. It is becoming a marketplace, a competitive arena, and a realm of open innovation. However, this expansion brings new challenges, chief among them, space debris. Earth's orbit is becoming cluttered with spent stages, fragments of defunct satellites, and microparticles that can damage working spacecraft. The ESA estimates that over 130 million objects under 1 centimeter in size now orbit Earth, each traveling at bullet-like speeds. Solutions are in development: nets, harpoons, and lasers to alter debris trajectories. But it remains a pressing issue requiring the combined efforts of all spacefaring nations. Quantum technologies in orbit future. Space technologies are increasingly intertwined with quantum physics. Quantum communication between satellites is already being tested, enabling unbreakable data channels. This will revolutionize everything from military communications to navigation. Moreover, quantum computers operating in space will perform simulations beyond the reach of today's supercomputers, modeling black hole behavior, galactic evolution, and more. The origin of life and astrobiology space also fuels our quest for answers to one of the biggest questions: how did life begin? Astrobiology is experiencing a renaissance. Carbon-based compounds found on meteorites and in the atmospheres of other planets suggest that life's building blocks, amino acids, lipids, nucleotides, are common in the universe. Some theories even propose that life on Earth may have been delivered via comets or meteorites. If so, then life is not unique. It may exist everywhere: beneath the ice of Europa, in Enceladus's subsurface oceans, Titan's atmosphere, or even as microbes on Mars. From sci-fi to reality, these ideas lead us to a future that seemed like science fiction yesterday, but today feels like a matter of time. Concepts like solar sails, interstellar craft propelled by light, are already under development. Projects like Breakthrough Starshot aim to send a probe to Proxima Centauri in 20-30 years. If it returns even a single image from the surface of a distant planet, it could rival the moon landing in significance. Long-term, humanity may build orbital cities, autonomous stations orbiting Earth, the Moon, or even Mars. Terraforming, though still theoretical, is a growing topic at conferences. One day, we might make other planets habitable, starting with atmosphere and temperature engineering. The fate of civilization. Among the star space is becoming not just a frontier of exploration, but a testing ground for civilizations. Survival. With overpopulation, dwindling resources, and climate threats, space expansion is no longer a luxury. It's becoming a necessity. Humanity stands at a crossroads: remain confined to one planet, or embrace the multiverse and become truly multiplanetary. And yet, despite all the technological progress, the most important driving force is still the human spirit, our drive toward the stars, toward knowledge, toward freedom. It's this desire that launches satellites, lands rovers, and searches for life in the cosmos. We don't just explore the universe, we search for ourselves in its reflection. Perhaps the greatest cosmic mystery isn't what black holes are, made of, or where life began, but why we keep looking up and dreaming of the impossible. We're just at the beginning, and the most astonishing discoveries are yet to come. Since the moment humanity first looked up at the stars, an invisible yet unbreakable bond has formed between us and the cosmos. This bond has not weakened over the centuries. In fact, it has only grown stronger. At night, when the lights go out and silence settles in, the stars seem to whisper, "You are not alone in the universe." And deep inside, each of us feels that our home is more than just a planet. It is a part of an infinite universe, full of mysteries, wonders, and possibilities. Modern astronomy is no longer just the observation of the sky through a telescope. It's billions of data points collected daily by satellites, orbital observatories, Mars rovers, and automated probes. It's colliders and quantum experiments that allow us to peer into the very nature of matter. It's thousands of scientists across the world who bring us closer every day to understanding who we are, where we come from, and where we are going. Recently, a series of discoveries shook the space community. Discoveries that didn't just add new lines to textbooks, but expanded the very boundaries of our understanding of reality. The Solar Orbiter space probe transmitted the first images in history of the sun's south pole. These images reveal the dynamics of solar magnetic fields, helping us understand the cycles of solar activity that affect Earth's entire climate. We have begun to see the sun not just as a source of light, but as a complex, living system that interacts with us in real time. Meanwhile, new moons continue to be discovered around distant Saturn, and each is like a world of its own. Some are made of ice beneath which warm oceans may hide. Others are rocky, cratered, with mysterious structures perhaps shaped by ancient geological processes. All of this challenges our very concept of life and expands the boundaries of the possible. If an ocean under Enceladus's ice can host microbial life, then there may be thousands of such crust-covered worlds, not just in our solar system, but far beyond. While some missions explore neighboring planets, others venture beyond. The James Webb Space Telescope has not only captured breathtaking images of distant galaxies, it has begun looking back into the past, to the very moment when the universe itself was born. Thanks to it, we've seen light that traveled over 13 billion years to reach us. The light of the first stars that ignited in the vast darkness after the Big Bang. Gazing into that light is like touching the very beginning of time. But the universe is not just distant, it also holds dangers closer than we think. Asteroids, comets, and space debris remind us that Earth is just a tiny platform in a turbulent and chaotic expanse. Asteroid 2024 YR4, while not posing an immediate threat, has sparked global discussions. How can we protect ourselves? How do we detect threats early? How do we build systems capable of deflecting or destroying an asteroid before impact? Answers are beginning to emerge. The successful DART mission proved that we can indeed alter the trajectory of a celestial object. The next step is to make such systems autonomous, scalable, and available for international use. After all, space is a shared responsibility, and defending Earth must be the task of all humanity, not just one nation. Space is increasingly becoming a place not just of scientific discovery, but of economic interest. Private companies are launching rockets, deploying satellites, building lunar module prototypes, and discussing colonization. SpaceX is developing the Starship Super Heavy rocket to carry cargo and humans to Mars. Blue Origin is working on sustainable orbital station technologies. China is building its own space infrastructure, while India recently completed a successful moon landing. This is no longer a competition. It is a collective step toward a new world, where space is no longer a dream, but a home. Yet behind all the tech, numbers, infographics, and plans, there remains the human being. Alone, yet curious. Fragile, yet determined. We are exploring not only the universe but ourselves, because when we look into a black hole, we're really asking, what if beyond that horizon lies another reality? Another chance? Another life? Every newly discovered exoplanet among distant stars is like a letter from the future. Perhaps somewhere out there, someone is also gazing at the sky, searching for other civilizations, asking the same questions. We still don't know if we're alone, but the very possibility of finding out is what keeps us going. The cosmos calls. Not as a threat, not as a challenge, but as a promise of an endless journey, of new discoveries, of new understanding. And who knows? Maybe one day, far in the future, one of our descendants will stand on the shore of an ocean on another planet, look back toward the star we call the sun, and say, "It all began with a single glance at the night sky.